Okay, it's Friday again. Thank you, everyone. Welcome to join TGI Pulsar episode 2. And we are going to talk about Kubernetes deployment. And it's our second time for live uh, uh, broadcasting everything about Pulsar on Friday. And if you enjoy my previous episode, and feel free to sign up on the check out the TGIP repo and suggest your topics, and we'll invite a PMC member of Pulsar committee to talk about a specific topic that you are interested. And my name is CJ. I'm a CEO and co-founder of StreamNative. StreamNative is a startup that are providing cloud native event streaming platform powered by Pulsar. And I'm also a PMC member of Pulsar and BookKeeper. I do a lot of work and on Pulsar, and I also do a lot of like hands-on sessions with different people and help people adopting Pulsar. So welcome to TGIP episode 2, and let's get started. And first thing I'm going to share what's going on, what's happening in Pulsar community in this week. And I think the most important thing or most exciting thing is the PMC published the first ever user survey report on Monday. And this report is done by after surveying 165 users from Pulsar community, and it tried to relieve some of the ideas about the accelerating rate of the global adoption and deterring how organizations are leveraging Pulsar to build their real-time applications, and highlights the some of the key features and uh, uh, functionality and how they are using by different companies. And it's 25 and 26 pages. It has a lot of details. I would recommend everyone to download it and check it out if you are interested to learn what is the current state of Pulsar community. And the second thing is I'm going to do an advertisement here is we are going to open source Kafka on Pulsar next week. And Kafka on Pulsar, it's a pluggable protocol handler that you can install to your existing Pulsar cluster, especially specifically installing the protocol handler to your Pulsar broker. This would enable your Pulsar broker speak Pulsar Kafka protocol, and the protocol handler is co-developed by StreamNative in OVH Cloud. And we are going to co-host a webinar on March 31st. And if you are interested in learning more about the details of the implementation of Kafka on Pulsar and how it enables new use case by collaborating Pulsar and the Kafka, these two popular messaging ecosystem, please sign up on this webinar registration link. So it's a Zoom webinar. So just go ahead to go to this form and sign up yourself. And looking forward to see you on March 31st. And let's start today's show. And so, as we did the survey, it shows that about like 50% of the users deploy Pulsar on Kubernetes. And just because Pulsar was designed in a way that separate the messaging serving from message storage, so it was designed to fully leverage the cloud native environment. So it's not surprised that Kubernetes is the top options for people choose to deploy Pulsar. But I know a lot of people also hit problems when they try to deploy Pulsar on Kubernetes. And the most common thing I've seen here is a lot of things happening when people deploy Pulsar to Kubernetes. They'll hit problems when the BookKeeper pods restarted, and when I try to deploy Pulsar Manager to monitoring my Pulsar cluster, but the Pulsar Manager never able to connect to the brokers and is not able to display any informations. So in this show, I'm going to walk through some of the highlights or checklist for what you need to take care of when you're deploying Pulsar to a Kubernetes cluster. So I basically listing out the Kubernetes deployment into a checklist. I think the checklist shows the most three important things you have to think about before deploying a cluster to Kubernetes. The first thing is how do your application is going to access your Pulsar cluster. That means you need to figure out the network related settings, like how to expose your service outside of Kubernetes network. The second thing is where do you store the data for Zookeeper and BookKeeper? I know container is very great for deploying steady service, but sometimes it can be challenging when you deploy a stateful service on Kubernetes. So you need to choose the right mechanism for deploying Zookeeper and BookKeeper. More specifically, you need to take care of how to deploy BookKeeper on Kubernetes. And the last thing is you need to figure out how to managing and monitoring your Pulsar cluster. Basically, how to collect the metrics and how to connect my Pulsar manager to my cluster. So that is in my mind, that is the top three things you have to think about before doing a Kubernetes deployment. And hence, I want to bring up the diagram I usually use for helping people deploy Pulsar into their environment. The most important thing is you need to have a network topology to understand what exactly your network topology will look like. So in this diagram I'm going to hide some of the elements first. Uh, okay. Okay. In So as a minimum, the minimum setup for people deploying a Pulsar cluster to Kubernetes, first you need the Zookeeper cluster. Zookeeper cluster for metadata storage. You need a set of book keys. The book keys is used for storing the data, and you need a set of brokers. That is the normal components you need for deploying Pulsar into an on-premise cluster, because in that case, your producer and consumer can access directly to the brokers. But the tricky part would happen when you're deploying this setup to Kubernetes, because the broker is running within a Kubernetes cluster, which has its own network. So if you have a producer and consumer outside of your Kubernetes environment, then how do your producer and consumer are able to connect to brokers? Because there's no connectivities between the producer and the broker. So the first thing you have to think about here is how I want to expose the service to outside of the Kubernetes environment, so the producer and consumer can connect to my broker. And a lot of people, if they have if they come from on-premise environment, they'll think, okay, I can use the host pod that provided by Kubernetes. I can advertise my broker to the host pod. Then the producer can just connect to the individual broker into host pod. You can do that if you have your own Kubernetes cluster, but it's very hard to do that if you run in a fully managed Kubernetes cluster on cloud. Like for example, if you're using GKE, AKS, then you have to figure a different approach. So that's what why we need a proxy in the in uh, in uh, in Pulsar. And the purpose of proxy is allow the producer and consumer connecting to your broker without directly knowing the network address of the broker. So basically, the proxy would be acting as a dedicator to dedication order request, receiving from a producer and consumer, and send a request to the right broker. So you need to have a proxy component in order to expose the service outside to your producer and consumer. And once you have the proxy component running, when you want to expose uh, the service outside to the producer and consumer, then you can set up a load balancer to do the job. Then the load balancer would handle all the connections that receiving from a producer and consumer, and the load balancer would find the right this loaded producer and connecting to that producer, and the producer would connect to the broker. So that would help your producer and consumer connect to the right broker. So in order to deep dive a bit into why we actually need a proxy, I actually have slides talking about how a producer and interact with your broker. So that is, I'll just give you a presentation about how this topic discovery and service URL and cluster work within Pulsar. Hope that would help you understand why and how producer and consumer connecting to your broker through a proxy. So the first common thing that people would ask is, how does Pulsar assign? So you need to figure out the first thing out is, how does Pulsar assign topics to brokers? Because that would determine how your client connect to the broker. So to give a simple introduction here is all the topics are managed in a hierarchical within Pulsar. So you have tenant, namespace, and topic. And this is a better diagram to show the hierarchical. So in a cluster, you might have a different tenant, like one tenant for data serving, one tenant for marketing. And within each tenant, you have different namespace. And under a namespace, you have many topics. So it's a kind of tree structure hierarchy. And all the assignment is actually happening in a namespace unit. So we take out the namespace and create a simple abstraction about only for a single namespace. So you have a tenant, you have a namespace, and under namespace you have several topics. And what Pulsar would do is it didn't assign individual topic directly to the brokers. So what it does is, first it create a consistent hashing ring for a given namespace. And within this hash ring, it would compute compute the hash key for individual topics, and assign the topic by the hash key to the hash ring. And the hash ring is divided into multiple bundles. Each bundle is basically a hash range. So the list of topics under a namespace is actually assigned to some of the namespace bundles. You can think about a namespace bundle is a collection. That is a collection for a subset of the topics of this namespace. So once you have this mapping set up, what Pulsar would do is it assign the topics by bundles. So it didn't assign individual, but it's assigned by a namespace bundle, or you can say by a batch of topics. So the assignment is basically done by a component called load manager. So each broker will run a load manager, and the load manager, all the broker would elect a leader, and the leader would become the the server that who is responsible for assigning the namespace bundles to the brokers. So the load manager would do the calculation, and based on the configuration of how many bundles you want for a given namespace, it would assign the bundles to brokers. So each bundle would be assigned to one broker, and the broker received that bundle would be the owner of the topics under this bundle. So that is how Pulsar assign the topics to brokers. So once the assignment is done, so you have all the information about how a topic is assigned to brokers. So the next question is, when a Pulsar client connect to the cluster, how does Pulsar client locate the owner broker who is serving the topics of a given namespace bundle? So um, the the assignment is happening in the namespace level. The namespace divided into a namespace bundle. Each bundle has an owner, and the owner is recorded in BookKeeper. So basically, every broker would have the information about how a bundle is assigned to a broker. So you can talk to any brokers that would be he would that broker would be able to figure out who is the owner. Uh, so when you have a client, you create a Pulsar client, you want to produce to a topic. The first thing the Pulsar client would do is it would do a topic lookup. So the topic lookup, it would send a lookup request to any of the brokers. So any of the brokers within the cluster is able to serve the topic lookup request. And if the broker figure out, okay, I'm the owner broker, then I would respond to the client, say I'm the broker. But if this topic is not owned by the broker who served the lookup request, then it will respond back to the client saying, this is the lookup result. This is your owner broker. So when client receive the lookup result, they will know which broker it should connect to for this topic. And then Pulsar client would create a persistent TCP connection to the owner broker, and all the subsequent produce and consume requests would be sent to that broker. So from this lookup logic, what you can see here is the Pulsar client need to know uh, need to know the network address for individual brokers that it has to connect connect to, and the client should be able to create a TCP connection to connect to each of the brokers. So that means you need to make sure your Pulsar client and your broker is in the same network environment. Otherwise, your Pulsar client is not able to connect to your brokers. And that's why if you running the broker within the network that is not able to access by the client, you need to figure out a different approach how the client can connect to the brokers. Otherwise, you are not able to establish uh, the TCP connection to the brokers. And one thing I want to call out here is if you use Pulsar before, when you specify the service URL, you can specify the binary protocol URL. So the service URL start with Pulsar. You can also use the HTTP lookup. That is because individual brokers already running an HTTP server for serving the admin request. So the lookup service is also exposed in this HTTP server. So Pulsar client can use HTTP protocol to do the lookup. But once you finish the lookup, you get the owner broker. The client is still create the persistent TCP connection to the broker for all the subsequent requests. So that's one thing I want to highlight when people using a HTTP service URL. So to summarize the Pulsar topic lookup logic, you can see is that the topic lookup request can be served by any broker. That means you can use any load balancing mechanism for sending the first lookup request. But after you finish the lookup, the Pulsar client needs to create a direct TCP connection to that broker. So client is required to have connectivity to the owner broker. Otherwise, you are not able to connect. And so once you realize that fact is, so all the service URL is for providing the load balancing mechanism for serving the topic lookup request. It doesn't do any load balancing after you receive the lookup result. So when you want to set up a high available service URL for your Pulsar client, you have a bunch of options. Because the lookup can be served both on binary and HTTP, so it opens up a lot of options what you can do. So first thing is you can use a DNS, and so you can configure DNS to mapping to individual brokers. So when you do either do binary lookup or HTTP lookup, the request can be forwarding, can be routing, and not routing, can be resolved to a given broker. So that is the first thing. The second thing is for sure you can bring up a load balancer uh, in front of all your brokers. So your lookup request can be load balancing between any brokers. Or if you don't have DNS, if you don't have load balancer, you can configure your client to use all the IP address or domain name of all your brokers. That means if you're using multi-host service URL, it's your client doing the load balancing. It's not the server or the hardware do the load balancing for you. And one thing I want to highlight here is even you say I put a load balancer in front of my brokers, the load balancer only help the topic lookup. It doesn't help the direct TCP connection that client need to connect to the brokers. So even you have a load balancer, it doesn't solve the problem if you cannot reach the address of the broker. So the next question is, because I run the broker within a Kubernetes environment, but I want my application access to my service outside of Kubernetes environment, then that fall into the case is a client cannot access the broker address directly. In that case, we have to introduce another layer. That layer is called proxy. Proxy means producer and consumer can connect to any servers, and the proxy would just do the load balancing for the connections that connecting from the producer and consumers, and the proxy would handle all the topic lookup logic and figure out what is the owner of a given topic and connect directly to the broker. So you have to put another component in front of your broker. So that's proxy. And let's take a look at how proxy would change the behavior of the topic lookup. Uh, so when we implement all the uh, protocols, introducing the proxy doesn't change how client interact with Pulsar cluster. So client still do lookup, so it can connect to any proxies. So when it connect to any proxies to do lookup, the proxy will forward the lookup request to any of the brokers. So this is the pass is the lookup. And once the broker receive the lookup request, and it lookup the owner of the broker, and it will respond back the owner to the proxy. So the proxy receive the lookup result, and it would modify the result and so uh, put the actual broker as a proxy to broker URL and send the result back to the Pulsar client. And when the Pulsar client receives that, it actually have two address. The first address is the physical address. It has to connect to the client should connect to, so it's the proxy address. But the response also contain another address called logical address. That means the actual owner of the broker. So when client receive the lookup result and try to connecting back to the cluster, it would use the physical address, which is the proxy address. So the client would connect to the proxy, and the connect request would carry on a proxy to service URL. So it will carry on the logical address to the proxy. So the proxy would know it has to create a TCP connection from proxy to broker. So once this connection is created, all the requests sending from Pulsar client to the proxy would be forwarded to the right broker owner. And all the logic would be handling by the actual logic would be handling by the owner broker, and the proxy would only do the package forwarding. So in that case, you can think about proxy is just a TCP proxy with topic lookup functionality. So it's able to look up the ownership of topic and forward all the TCP package from client to the right owner. So that is the kind of a short presentation to help you understand like um, how topic lookup work and why we need a proxy to deploy for your Kubernetes environment. So that is the first thing you need to figure out is you need to figure out the proxy. So you need to deploy a proxy. You need to configure the load balancer. And the second thing is I want to highlight a bit here is the when you set up a proxy, another thing you need to config is how proxy discover broker. Pulsar actually provides a lot of flexibility for you to config how you want to discover um, brokers. Um, that is the second piece you need to figure out is how you want to deploy, how you want to configure your proxy to talk your broker. So if you look at some of these settings, let me just zoom in a bit. So if you want to take a look at the configuration provided by the proxy, you actually can see in the broker discovery part, Pulsar provide two different mechanisms for you to configure how proxy can discover broker. For sure, the most simple thing is you can just configure the zookeeper server you want to the broker use. So you can the proxy can just look up the zookeeper information to figure out what exactly the available brokers in the cluster. And the other way is you can just use configure broker service URL, so you don't need to set up the zookeeper. Because in most of the case, what the proxy needs is it need to do topic lookup, and the topic lookup you just need um, a broker service URL, and the broker is already providing any broker can serve the topic lookup request. So some of the users would ask, what is the preferred way to configure the broker discovery? Uh, in a lot of cases, I would suggest go with the broker service URL approach. Why? Is first thing is when you configure your connection, sorry, when you deploy broker on Kubernetes, you will give a broker a headless service. So this headless service, you can think about it's already kind of a DNS-like service provided by Kubernetes. So when you provide the service URL to Proxy, and when Proxy talk to the brokers, the headless service can do the load balancing for the request sending to this service. So you are relying on Kubernetes to help you do the load balancing between the brokers. If you configure the zookeeper approach, that means Proxy is receiving the request from uh, the proxy receiving the list of brokers from zookeepers, and you would do the round robin approach to figure out which broker I should connect to, and that all the round robin, all the load balancing logic is happening in the broker side, and in my opinion, it's not as efficient as the load balancing service provided within the Kubernetes. So with that being said, I would recommend go with the configuring the broker service URL. But sometimes, and I also want to point out another fact is when you're using Zookeeper, you usually face a problem is no active brokers is available in the list. That would happen if the zookeeper session, the zookeeper session proxy has is to disconnect are broken. So you would see all the brokers is ejected from the zookeeper cache, and when you try to hit the proxy again, and proxy will see, oh, there's no active brokers alive, so it's not able to send out any requests. And I believe that is a very common case that people have been the common issue people already hit when they're using proxies. So that's why I would suggest go with the broker service URL for configuring your service. So that is the network part. Okay, so for the most challenging part is actually the bookkeeper part. And in order to understanding the bookkeeper part, I would first do a quick, I will probably deploy a Kubernetes cluster in my environment. And so I already have a GKE cluster running. I can just run uh, helm install. So stop here. And for the when you deploy bookkeeper, so there's actually a few things you need to figure out is you need to figure out the bookkeeper identifier you need to use. That is because bookkeeper has a very strict verification mechanism. It need to ensure you use a stable bookkeeper identifier, and the bookkeeper identifier should be not change during the life cycle. Otherwise, you would cause the cookie does not match or invalid cookie exceptions when you try to restart. And I will explain why we need a stable bookie identifier when we're looking into a cluster. So that is the first thing you need to make sure you have a bookie identifier. So when you want to deploy a service to um, Kubernetes, you need to figure out which kind of service you want to use or which controller you want to use for deploying Bookkeeper. So there are a bunch of the kind of controllers, like deployment is a very common one, Stateful set, replica set, daemon set. But as we said, for Bookkeeper, you need a stable bookie identifier. With that being said, there's only two options left for us to choose. One is Stateful set, because the stable set it provides a stable unique network identifier, and also it provides a stable persistent storage and all the automated rolling updates, things like that. And daemon set is it's running on individual servers. So if on your server you have this server have a physical IP address, host name, you can use the host address and host IP as a stable identifier. So these are kind of two options. But uh, the reason we kind of bring in daemon set into this picture is before Kubernetes 1.14, Stateful set only support persistent volume. So you need to have set up a storage provisioner in order to provisioning persistent volumes. So if you want to use local disk, or if you want to achieve high higher performance using local SSD, the only option you can go is daemon set. But after Kubernetes 1.14, the local persistent volume is already GA. So you are able to config uh, using local persistent volume in the stateful set. So you don't need to considering the daemon set anymore. So after that, our recommendation is always go with stateful set for deploying your bookkeeper, and because it provides your stable network identifier, and it's able to access persistent volume and local persistent volume. And since I bring up the persistent volume and local persistent volume here, one thing you need to, for a lot of people need to understand is uh, what's the impact of using persistent volume and what's the impact of using local persistent volume. So using local persistent volume, you have direct access to the local disk. attached to the Kubernetes work node. So you can use that to provide like lower latency, higher throughput. But if you're running on cloud, the local persistent volume is usually attached to EC2 VM or GKE VM. Once the VM reboot, the disk might be gone. So in that case, if you want to provide a higher guarantee, you might when you're running on cloud, I think persistent volume is a bit the right choice for you running on cloud service. But if you are running Kubernetes on in an on-premise environment, local persistent volume is the way for you to tune the performance in as well as the latency. So there's not too much difference between persistent volume and local persistent volume in terms of how you want to deploy a BookKeeper cluster to that. Okay, let's see if I have the cluster running. Okay, so in terms of the let's see. Okay, I haven't executed that. Okay. Uh, So I would do a simple kind of install a simple cluster like using the local persistent volume. So in order to install a local persistent volume, when you create a GKE cluster, you have to create a GKE cluster with local SSDs. And you have to create a local storage provisioner to provision the local persistent volume by using the local SSD that you provision in the GK cluster. So I actually have a script that is doing the create a container cluster, basically a GKE cluster, like within by specifying the dash dash local SSD. And I already created the cluster before this session, and so I have the cluster ready. But before you want to use local persistent volume, you have to install a local storage provisioner in order to make sure you are able to provision a local persistent volume using the local SSD. So actually, I wrote a simple chart doing the local provisioner, and the chart is it's basically running the provisioner as a daemon set. So it's running on individual servers. So this is let's see, it's a daemon set. So it runs on individual Kubernetes servers. And what it does, it was looking into using the local storage provisioner to provision local persistent volume using the local SSDs. And it exposed that as a storage class called local storage. And when you create the persistent volume for BookKeeper, you can reference this local storage. So the first thing we will need to do here is we need to install, let's say that's called local storage provisioner and provision. So once you install, you can use the kube control to figure out to see if it's running. So as you can see here, it's actually try to create a local storage provisioner, and it's because I have 4 nodes, so it's actually running on individual cluster, so individual node. So if you want to check here, is you're able to see it actually try to mount some of the local PVs to using the disk. So once you have, so for deploying the local persistent volume, you have the mm, local persistent volume ready. Then you are able to deploy a Pulsar cluster or deploy a BookKeeper. So in order to use the local percent volume, because we expose the local percent volume as a local storage class. So when you write your Pulsar chart, uh, within the chart you can use let's say, so you can specify the storage class as the local storage. And since we put this into Helm chart, we actually control the chart whether it's all the stateful components using the local chart, local storage, you want to use individual. So in my example, I would just use the, sorry, let's see, one of our example that is the local PV. So we would actually, I think that setting is wrong, but we need to deploy that using local storage. So that basically enable the settings to use a local storage as the, actually, I think we write this down. For the chart to be able to using the local storage. I think we write, I wrote something wrong in the chat, but we'll see. So when then we can install a Pulsar chart, install dash value. Let me see. Helm, sorry. Uh, History, Helm. Okay, so we have this. So we can install a local PV chart. Um, so we will see how it goes. Oh, okay. I see. I think I disable create a namespace. So I need to create a namespace. Create namespace Pulsar. I can install the chart. Oh, helm ls helm delete. Okay, so let's install this again. Okay, now you have the Helm installed. Then we can check out the status. In this, I would recommend to check out a tool, very cool tool called K9S. It's it's a Kubernetes DOI to manage the cluster. It's very cool, and we can see. So in a lot of cases, when you launch the Kubernetes cluster, you usually use kube control to run individual command. But K9 is basically putting release into a terminal, so you can use that terminal uh, to watch like how things is actually happening. So for example, it's listing out all the status of individual part. And if you want to go to one part, like for example, if I want to go to this part, I can just type L to check out all the logs, and I can exit and tap S, then I can go to the actual container. So it's very cool. And let's see, I think we're still downloading the images. Okay, now we are running. It actually deploy a ZooKeeper cluster and BookKeeper cluster with 4 nodes because I config the example size to be 332 and I want the torrent one bookie to go down and bunch of the brokers and bunch of the proxies and I deploy the full monitoring stack including node exporters to measure all the system metrics and Prometheus for collecting all the different components metrics, and Grafana for dashboarding, and the alert manager for alerting, and also parser manager for uh, managing the parser cluster. So we can see here is okay, now we have to keep a cluster up running. Then the other parts will be up running very quickly. Okay, so you can see here is the bookies. So if you want to go to the bookies, let's check. Uh, so in order to understanding the identifier and how important to that is under the bookkeeper cluster. So the bookie is actually store a cookie file into the directory in manager, and that cookie file is actually called version. So if you check this, you can see what information is stored here is your bookie host is the bookie identifier and the general directory you are using and the ledger directory you are using. And the incident ID is the whole instance of the cluster that was introduced, that is more useful when you run a machine in on-premise environment. You can use that to prevent people removing a bookie cluster from one cluster and put into the other cluster to cause any data inconsistency. So bookie is very it does a very strict check on the cookies. It will compare your configuration to make sure you're using the right general directory, right ledger directory, and also the bookie host is same across all the general directory, and it also store the information in within ZooKeeper under the ZooKeeper cookie uh, metadata. So if we go to so just check here is it's this cookie information. Just remember that. And if we go to let's go to ZooKeeper and just go to any of the container. Let's go to Pulsar ZooKeeper shell. Then you can see the there's a JNode called ledgers. That is the JNode for storing all the bookie information. And the ledgers, there's a cookies. And in the cookies, you can see it's using the bookie identifier as the cookie ID. And uh, if you check that the information within these cookies, you will see the exactly same as the as what you can see in the version file found on the bookie directory. So you need to make sure these cookie file are in match when you reboot the bookies. Otherwise, the bookie will not start if you have a different settings. So a common way people see is when they restart the bookie pod, they'll find okay, it's no invalid cookie exceptions. That most likely is the bookie host is using IP, and when you're running a pod within Kubernetes, each time you restart the pod will be assigned a different IP. So in that case, you need to use the host name as the stable network identifier for the bookies. So that is the BookKeeper. Uh, and the last thing, I think we are running out of time, but the last thing I want to call out here is, so there's a component called auto recovery that people usually kind of run as part of bookies. And but when you're running on Kubernetes, it's recommend you can run outside of the uh, uh, outside of bookies, so you can run as a different uh, uh, different deployment. Like you can have a different container is only running auto recovery. Running outside of Bookie has some benefits. Is you can use kube control scale to scale down the auto recovery or scale up the auto recovery in order to control how fast you want to do the replication. So that is the flexibility you want to get by leveraging the power of Kubernetes. Okay, once you have the core cluster up running, the next thing is you have to see how I want to monitoring the cluster. So you have to set up Prometheus to collecting all your metrics. So you need to make sure your Prometheus setup is able to access all the components here, the broker, bookie, zookeeper, and the proxy. And you need to set up a Grafana dashboard for visualize the settings. And you probably want to set up a Pulsar manager for managing the cluster. And I think it's easier for people to kind of configure Prometheus in Grafana, but sometimes it feels tricky for people to understanding how Pulsar manager talk to the brokers. So in this case, Pulsar Manager is actually talk to the brokers. So the URL you have to provide in the Pulsar Manager should be the service URL of this broker, and that should be the URL you use when you access the cluster within this Kubernetes environment. You should not put the load balancer in your Pulsar Manager, because in that way you are not able, the Pulsar Manager is running within the Kubernetes cluster. It's not able to connecting to the load balancer. So just to give you a quick idea here is we actually, actually expose some public IP of that kube get service. Also, so we have Grafana. Okay, so this is 330. Let's see. So you can access the Grafana and also the Pulsar Manager. Sorry, this is Proxy. So the default is Pulsar. So as you can see, it's actually if you're using the open source Grafana dashboard or using StreamNative Grafana dashboard, you're able to see a bunch of the settings that give you some of the dashboard for individual components. So on the Pulsar Manager, you are able to. So the first thing when you get into the Pulsar Manager is you need to provide the environment. Environment is basically the cluster you need to talk to. So when you put the environment name is you just for yourself. You can just use any name. The service URL you need to provide is actually the broker service URL that a Pulsar Manager can access to. So in this, because I have headless service is called Pulsar dev broker. So in here, what you need just put is your broker headless service and the service URL. And in this step, you need to make sure your Pulsar manager is able to connect to the service URL. Otherwise, you're not able to see that. And once you get into that, it would be able to figure out what are the tenants, and then you can create your own tenant. Let's see TGIP, and you're able to specify the cluster and confirm, and that will give you the tenant. So just make sure here, what you can see here is all the cluster information, including the service URL, would be actually the service URL within your Kubernetes cluster. You shouldn't use the service URL you expose publicly, because your Pulsar manager is running within the cluster. And the most important thing is Pulsar Manager also need to be able to connect to individual brokers, because some of the operations require Pulsar Manager to operate directly on the broker. So that is all the content I want to